in the chat. So I'm interested in what you discovered in terms of, I mean, at a basic level of pattern recognition, just what the main tasks that people do in the production machine learning lifecycle are. What did you find out?
Yeah. I think a good answer to this is what the textbook says, and then what we found that is different from what the textbook says. And what the textbook will tell you for machine learning is first you collect data, step one. Step two is you train a model. Step three is you evaluate that model on a holdout data set, make sure there's no overfitting. And then step four is you deploy. And what we found is that we can still categorize into 4 steps, and maybe the data collection part is similar, except for it's more of a loop. Like every, I don't know, week or so, we want to collect new data. We want to make sure there's some QA on that data or something. But the rest of the steps, the last 3 steps, are totally different. The second step, what I said before, model training, is actually experimentation in general, whether it be training new models, whether it be trying to source new data or adding new features. There's a lot of ways you could think about improving a model. And a lot of the participants actually preferred to look into finding new data that gave new signal, or making features more fresh instead of stale features that they had before. So that's kind of step 2. Stage 3 in the process was we call evaluation and deployment. So evaluation is not a one and done thing. What happens is evaluation is kind of done maybe on a holdout data set at first, and then it's deployed to a small fraction of users. And then when the model shows a little promise there, increasingly it's deployed to more and more users, as we learn more about what it can do, what it can't do, what failure modes exist, how do we go and patch problems until we've kind of gotten to the full population. So key takeaway is evaluation is not a one-time thing. It is a loop on evaluation and deployment, a multi-stage deployment. And then the latest, the step 4 we found was this overall monitoring and response stage, which was when you do have these models in production, what is their live performance? If you see the performance dropping, what are the bugs? Where are the bugs? How do we respond to them quickly? Whether that be actually trying to go do root cause analysis or simply retraining the model, there is a stage around making sure that there's little downtime for these services. So we have those 4 stages shown in the first figure in the paper, and it was interesting to several of us authors that they don't match the textbook. I think that's like kind of the narrative that we want people to take away.
Absolutely. And let me ask, are these different steps? I mean, there's an iterative loop happening there, but are they kind of coupled in some way? Because you could imagine monitoring and validation aren't always separable, right?
Totally. I'll say that monitoring is kind of done across the stage, or kind of in all of the stages. People monitoring their training jobs, people monitoring data collection. A lot of the times there's human in the loop processes to collect and label data, to verify some quality. Whenever you see a failure on the ground, to go and collect examples that look like that failure so you can go back and augment your validation sets. So in that sense, there's monitoring all over the place. But the one stage that we found that was super iterative in itself was evaluation and deployment. Evaluations data sets never stay the same. They're always changing, they're always growing, especially in tasks or domains where failures have such a high cost. Like autonomous vehicles are a great example of a failure is a really high cost. When we observe one, we need to make sure that we have no more failures like that. So how do we go and invest efforts into making sure our holdout data sets, whenever you evaluate your models, new models in the future, they're also robust to the problem.
Yeah. And I suppose drilling down even a bit more into data collection, and I think this is one thing that you're getting at. In textbook data validation, you're given a holdout set, right? As opposed to be actively getting that data and validating it and making sure it's the right data, then using it as a validation set. There are feedback delays there, all of these
Totally.
things, right?
Totally. I feel like I was never taught this in a machine learning class. Nobody taught me how to actually evaluate a model. It's not like I need a big checklist. I just want to know if I were to be a machine learning engineer for a month, not just one time, what do I do about my validation set? Do I keep it the
Mm,
same? Do I grow it? When do I add to it? What do I add to it? I think this in
yeah.
itself, super interesting problems for people to consider.